Hello everyone. What we're going to look at today is sort of a bit of circle mensuration. It sounds more impressive than it is. Circle mensuration. In other words, it's a lot the measurement of circles. Okay. Just firstly, I just want to go through some terminology. So I'll just draw a bunch of circles. Let's see how we go. Sorry, there's a guy next door doing leaf blowing, and I was waiting for him to finish. Seriously, he's been doing it for like, I reckon, an hour and a half. So I haven't got enough time. Kids are coming home soon. I need to get these videos done. So sorry about that. Firstly, I just want to define what a bunch of different things are. So what is a chord? A chord is just a line that goes across the circle. Okay, so that's a chord. It can be anywhere, sort of thing. An arc is what goes around a circle. Okay, so if you're going around the perimeter of a circle, that's called an arc. Now, if you're going around the short way or the long way, they're called two different things. Oh, that was hideous. So let me do that again. Leaf blower man may have finished, but we'll see. So there we go. So that's called the minor arc. Okay, so it's the small arc, and this one's called the major arc. Okay, the big one. So they're the sort of the two different things you need to know. If we have a chord like that, and we've got the area between there and the edge of the circle, we call that a segment. And again, you get the minor segment, and you've also got the major segment. Okay, so there's your two different types of segments. And the other thing you need to know is a sector, and a sector is just a piece of pizza. Okay, so there we go. We've got a minor sector. Actually, one more circle, and then you guessed it. We've also got a major sector, and there's your Pac-Man. Okay, so there's your major sector. I reckon he's finished. There we go. So there's just your terminology that you need to know about different names for different crap. Okay, and then you've got a whole bunch of different formula for figuring these out. And I'll just write them all down because they're good to know. Now, it's really important to know if you're in degrees or radians, because as with most things in maths, it actually turns out to be a lot simpler if we work in radians. And so you'll just see here the difference. Okay, so the formula for arc length, okay, the length along the edge of the circle. If you go around the perimeter of a circle, how long is that arc? And the formula, I'll write them in red. Formula for those, for degrees. We'll just think about it. If you've got some angle theta, and these is all if you've got angle theta, radius r. Okay, so that's what we're talking about. If you think about it, the arc length will be theta over 360, so the fraction of the circle multiplied by 2 pi r. Okay, that's all it is. I'll do all the degrees, and then I'll do the radians now. So that's it. That angle divided by the total angle of a circle times by 2 pi. It's just what fraction of the circle is it. For radians, all we need to know is, well, what fraction of the circle is it? So if we're measuring theta in radians, then we divide by the total angle around the whole circle. So in a whole circle, there's 2 pi radians all the way around, and we multiply that by 2 pi r. Now you'll see that there's a 2 pi r on the top and the bottom, so that is just theta r. Okay, so that's our formula, which is, you can see it's much simpler than that. You just multiply the theta by r to get, if it's in radians, and that gives you your arc length. Really simple. Okay, let's go to the length of the chord in this situation. Okay, so chord length is sort of just going straight across now from point to point. So chord length, I'll prove these in class, but I'll just write them down for now. And your chord length will be 2r sine theta over 2. Okay, so that's in brackets like that. And it doesn't matter, degrees or radians, that's the same formula. Because we've got sine in front of it, degrees and radians doesn't make a difference. Okay, in this case up here we didn't have it, sine or cos or anything. So there's your formula for chord length. A formula for sector area. Remember, a sector is a piece of pizza, and so all you're doing is it's a fraction of a circle. If you're in degrees, what fraction is it? It's theta over 360 multiplied by the area of a circle. So there's your formula if you're in degrees. What about if you're in radians? Well, again, if your theta is in radians, then it's the fraction of the whole circle. There's 2 pi radians in a circle, and so it's theta over 2 pi multiplied by pi squared, and so those pi's cancel, and so what you get is theta over 2 squared. So there's your angle, and you can again see it's a little bit simpler than that one, but not too bad for that. And finally, we've got sectors. We also need segments, segment area, and segment area, remember, is just you remember what we're looking at. The segment is I'll just write here just so I can think, is that there. So we're thinking, what is the area between a chord and its edge, and we're still talking about r and theta in this case. And so the formula for that is, you can think about it, it's the sector minus the bit that's in the middle, and I'll show you this in class again, but what we've got is theta over 360 pi r squared, so that's just our sector area, and minus, we can use the area of sine rule. The other part of that is half r squared sine theta. That's what we're doing is the area in that little triangle there. I'll show you that in class. If you're in radians, it's much simpler. It's just a little bit simpler. Half r squared theta minus sine theta. Okay, so there's your formula there. You could take half r squared out of this as well. A little bit simpler. So there's all your formulas. To be honest, I could show you some examples, and I will. But to be honest, it's just using the formulas. Make sure you know you're in degrees or radians, and just plug in the things. So I'll just do 1 or 2 examples because you guys are smart and you can figure out how to plug numbers into formulas. Okay, so find the chord length. Oh, I'm just making something up here. Okay, so I've got this and that, and we want to know. Oh, it's supposed to be a straight line. It was not there, and so we'll say that's 2, and we'll say this is 32 degrees in there. Okay, so our chord length formula is 2r sine theta over 2 is equal to 2 times the radius of 2 times sine 32 over 2 equals blah blah blah, and plug that into your calculator, figure that out. Make sure it's in degrees. If your angle's in degrees, make sure your calculator's in degrees mode. Okay, so make sure of that, and so do that. So that's all it is. All we're doing is plugging into formulas. Probably the most interesting example is for a segment area, and so I'll just quickly show you an example of that, but I'm not going to tell you how to suck eggs. All you're doing is plugging numbers into formulas. So we've got a circle, and let's say we've got that. What we want is a segment area. Okay, so there's our we've got our sector, and what we want to know is this area in here. Okay, so our segment area there, and I'm just going to make up numbers again. Let's just say 3 meters, and let's say we've got I don't know. Let's go in radians this time. So if let's just say, should we go 2 radians, or we'll go pi over. We'll go 3 pi on 2 radians. Sorry, that's 3 pi on 2 if you can't read that angle there. Okay, and so what we've got, if we're at the segment area, again plug in formulas. Segment area A is equal to, so the formula is half r squared theta minus sine theta equals half 3 squared 3 pi on 2. Is that right? 3 pi? I meant 3 pi on 4. I'm a bit of an idiot. Otherwise, just excuse me while I just change that to a 4. Okay, 3 pi on 4 radians, so just change that to a 4. If I knew how to use my eraser tool, I would do that. 3 pi on 4 minus sine 3 pi on 4 equals half times 9, so that's 9 over 2, and we've got 3 pi on 4 minus. Now, let's just have a think about this. What's the sine of 3 pi on 4? Now, 3 pi on 4 is here. Okay, so it's... Oh, I just cannot draw those in. Anyway, that's that angle there, 3 pi on 4, it's 3/4 of pi. So it's the same as the sine value here, which is at pi on 4, and that is root 2 on 2. Okay, so sine 3 pi on 4 is root 2 over 2. And if you wanted to keep your exact value, then you'd leave it like that. Would you simplify it more than that? You could maybe change it to 9 over 2, 3 pi minus 2 root 2 over 4. It's not the stacks needed, to be honest. Maybe you'd have to have that times 8. Let's just do that. So times the top line by 9, so 27 pi minus 18 root 2 over 8. So that's probably your neatest answer. Again, if the question wants it as it doesn't ask, then you want an exact answer. If the question asks for an approximate answer, you'd chuck it into your CAS calculator to get that answer. But to be honest, just use the formulas and use your calculators and give it area. Okay. And in this case, the answer would be in meters squared. So I just have to make sure meters squared. And there you go. Thanks.